Hello students, welcome back to the class. So today we'll be solving another set of questions, and the question states as: consider the charges Q, Q and minus Q placed at the vertices of an equilateral triangle. What is the force on each charge? So the question here says that we are having three charges and the magnitude of the two charges Q and Q. But the magnitude of the other charge is also Q but having the opposite polarity. Okay, the two charges are positive and the last charge is negative in nature. And where are these charges kept? These charges are kept on the vertices of an equilateral triangle. We know what is an equilateral triangle. Equilateral triangle is a triangle having equal length of side and equal angles. Okay, equilateral triangle, equal length of side, equal angle. Now in this question we have to determine the force of Q placed at A, Q placed at B and Q placed at 3 in between themselves itself. Okay, see, Q placed at A will have some force with the Q which is placed at B and with the QC. Similarly, QB will have some force with respect to A with respect to C. And the third case, in the similar manner, QC with respect to QA and QB. So we have to find these forces on each charge due to other two charges. Okay, so it is an equilateral triangle. The things which we need to understand over here is our length is same, this length is same, okay, this length is same, this angle is same, angle over here and over here is same. Now I will draw the triangle once again to explain you what exactly is happening. The diagram itself is self-explanatory, but I will draw once and explain it to you so that you can understand what this diagram of triangle is stating. I will just change the vertices. I will take the top one as A. On A we have a positive Q charge. This side I will take as B, which is again is having a positive Q charge. This one C having a negative Q charge. So changing the vertices in an equilateral triangle will not change anything, because it's an equilateral triangle, everything is equal. So I changed it, and now we will find the force of A on B, which will go in this direction. Okay, first we will consider the charge B. Charge B is having force from where? Charge B is facing force from A and from C. Okay, from A the force is going in this direction and from C the force is going in this direction. So now we need to find a resultant of it. Similarly, the force on C is due to A and due to B, which is having this direction. Again, in similar way, the force on A is due to C and due to B. Okay, this is well understood from where the forces are coming. So this is how the distribution of force is happening. Okay, now we'll come back to our original diagram. So the force from A to C is going in this direction and force from B to A is going in this direction. This is AC force, this is BC force, and this is the resultant of the force. This is the resultant of the force which is on A due to B and C. Resultant due to B and C on A. Similarly, this is from C to A, and this is from C to B, and the resultant is coming over here. This is F3, which is on C due to A and B. Similarly, from A, this is the direction, and from B to C, this is the direction, and the resultant is coming in this direction. So it is on B due to C and A. So this kind of configuration we are getting. Why? It should be all outside, right? The way I have explained, I have made all these in the outside way. But just see, C is here, A is here, B is here. Okay. These two charges are positive Q, positive Q. The most important thing which we have read in the first class itself is that like charges repel each other, repel each other. What is the case of the unlike charges? Unlike charges do attract each other. Okay. So like charges attract each other. So what will happen now is C will attract A in this direction. C will attract A in this direction, and A will attract C in this direction. So the vector will go like this. This is minus Q. Similarly, C will show force of attraction, and B will also show force of attraction in this direction. But when it comes to A and B, they are what? They are like charges. They will show repulsion. So the force will be in this direction from B to A, and from A to B the force will be in this direction. Now what we will use over here? We will use the parallelogram law of vector addition. Parallelogram law of vector addition. Fine. So while using this law, from here to here resultant will be in this direction. From these two resultant will be in this direction, and from these two resultant will be in this direction. Hope you understood how we have taken the direction of different forces. Okay, it is based on the charge. Either it's a positive charge, or it's a negative charge, or it's a mixture of a positive or a negative charge. One should remember the fundamental principle of the forces between the charges, and that is whenever we are dealing with the like charges, they will show repulsion, and whenever we are dealing with the unlike charges, they will show the force of attraction. So here the point to be understood is C is our negative charge, A and B are positive charge. When we take the relation of A and C, these will show force of attraction. Hence, the force line are going towards each other. In the similar way, when we see or approach the system of B and C, these B and C are having unlike charge system, and hence will show the force of attraction, and hence these vector lines are going to each other, going in the same direction. But when we consider the system of this A and B, when we consider the system of this A and B, they both are same charges, positive Q, which will show the force of repulsion, and hence see the vector lines where it is going. Vector lines are going in the opposite direction. One is going right, one is going left, because they are showing the force of repulsion. Okay, so this is how we made the lines. Once you understood this, after that the question is very simple. We have to put the formula and know the answer. That's it. So to find out the resultant here, what we have used? We have used the same parallelogram law of vector addition. That is like a standard thing we have to use whenever we are dealing with the vectors and electric forces. We need to use the vectors addition laws. Okay, we cannot simply add them because these are not scalar quantities, these are vector quantities. So let's come to the solution. As I hope we have understood what is our problem and what we need to find out and how we are going to approach to this question. So now let's go to solution. Let force exerted by each charge be F equals to Q square by 4 pi epsilon naught L square. This is the force by A, force by B and force by C. Force by A, force by B and force by C. Okay, I'll erase this diagram. See this one. Please copy it down. For a minute I'm giving you some time. Copy it down to understand. Okay. Now I'll just erase it so that I'll get little more space to write up the solution. Okay, see from where does we are getting this one, this force equals to Q square by 4 pi epsilon naught into L square. We have seen this this one triangle is an equilateral triangle and its side is L. The triangle's side is given to be L. Okay, so from here we get the side of the triangle, and we know Coulomb's law of force, how we are giving it. F equals to K into the two charges which are into consideration and distance ka square of between them. The distance which is between them, we will take the square of that distance. Okay, so this 1 by 4 pi epsilon naught is Q over here. This value is K over here, and Q square we have taken because our both the charges are same. We are dealing with same magnitude of charge. Same magnitude of charge. We are dealing with same magnitude of charge. And from where does the L square came? L square is the length of the side of triangle, which is the distance between the two comparing charges. Distance between the two charges which are under consideration, Okay, so we will get the force over here and force over here using the Coulomb's law of force. But what about this resultant force? From where does we will get the this force? So force F12 equals to F13 equals to F1, F21 and F23 and F31 and F32. Okay, these all forces are same. I will write over here, just copy it. Force 12, force 21, force 31, force 32, force 13, force 23. These are the six forces we are currently dealing, and all are having the same value F, which is equals to K Q into Q by L square. Okay, this is the value. So the resultant F1, which is the resultant between our force F12 and force F13, making an angle of 120 degree. This is the external angle of triangle. Okay, look up at the right corner of the slide here. When we are dealing with a triangle, this is x1, x2 and x3. Okay, 1, 2, 3. What is the value of this fourth angle? This is external angle. This is external angle. Okay, I will write over here. See the top of the slide. External angle equals to sum of opposite two internal angles. Okay, so this is our external angle and opposite is 1 and 2. In equilateral triangle, what is the angle made? It is 60 degree. So this is also 60 degree, this is also 60 degree. 60 plus 60, how much is it? it is 120 degree. So the angle made for F1 is 120 degree, angle made for F2 is also 120 degree. See the bottom of the slide, angle for F1 and angle for F2 equals to 120 degree. But when we go for our C option, angle for F3, it is how much? It is 60 degrees only, because we are dealing with an internal angle here. Okay, internal angle here. Fine, let's come back to the solution. See, we have taken all these forces as F. So this will be F1 square plus F2 square plus 2F1 F2 into cos 120 degree. Now this F1 square plus F2 square will add up, will make 2F square. This 2FF will be 2F square once again, and cos 120 degree is cos 180 minus 60 degree, and it will come cos 60 degree, cos minus 60 degree, and this value 60 degree, how much is the 60 degree of cos? It is 1 by 2, like cos 60 degree equals to sine 30 degree. So minus 1 by 2 is the answer over here. So this turned into the numeral value of minus 1 by 2. This system 2 and 2 will cancel out, and it will become minus F square. So 2 times F square minus 1 time F square, how much it is left? Only F square is left, which is under the root. When we remove the root, we are left with F. So so F1 equals to F. We have found the magnitude of F1 resultant on A, force resultant on A. Okay, now moving on to the next slide. So over here what we are having, now we will find the F2 ka value and F3 ka value. Okay, F2 is the resultant force on B due to C and A. Here also the angle which is made by F2 is 120 degrees, and F3 is force on C due to force of A and force of B, and here the angle which is made by the resultant is 60 degree. One thing which I aim to explain you in the previous slide, from where does this formula is coming. We have this formula by the parallelogram law, and it is written as resultant force equals to force on one vector plus force on second vector plus 2 times force 1 into force 2 into cos of theta, the angle between the two forces. But as we have seen, all these forces are equal to F. So F1 equals to F equals to F2. Hence we are taking F everywhere. Okay, I hope there is no confusion from where does the formula come and how we are substituting the value of F1 and F2. In the previous slide, as you have seen, I have told you the force on each and every charge due to other charges is equal, because they are placed at equidistance. Okay, force on A due to C is F, force on A due to B is F. But what is the resultant force when the two forces, force due to B and due to C, meet on A? What is the equivalent force is coming? That we are finding through this formula. Okay, so F21 and F23 are the resultant forces here. Substituting F square plus 2FF cos 120 degree, as we have seen. See, I'll explain this one more time. The formula, trigonometric formula, cos pi by 2 minus theta equals to cos minus theta equals to minus of cos theta. This is in the trigonometry. Okay, this is one formula how we are getting cos 120's value. Fine. So adding up all the things, substituting the value of cos 20 over here, we are getting f2 also as f. Okay. Now we will move on to the C. Here what we have seen the value of theta over here is 60 degree. Like this is our triangle, this is our force 3-1, this is our force 3-2, and here we are getting a resultant force F3. Okay. So what is the angle made by the two forces? This is the angle made by the two forces whose value is 60 degree, and hence same we are substituting over here. So it is like, I will solve for you, just come to the right corner of the slide. F square plus f square plus 2f square cos 60 degree. This is whole under the root. Okay, and it will become 2f square plus 2f square cos 60 degree is 1 by 2 under the root. Now this 2 will cancel out with this 2. 2f square plus f square under the root. This is 3f square under the root. Now what is root squared of 3? It is under root 3. What is root squared of f? It is f square, it is f. So what is the value we are getting? Under root 3 into f. This is the value we are getting for f3. Okay. As we have seen, the value of f is, value of this f is k q1 q2 by r square. Here q1 equals to q2, hence we are getting equals to q. So f equals to q square into k by l square. Value of r square is l square, that is the length of the triangle side. Okay. So resultant F1 on A, resultant of force on A is given by F q square by 4 pi epsilon naught into L square. Similarly on Q2 it is given as q square by 4 pi epsilon naught L square, and at Q3 similar way we are giving it the value of under root 3 into force F. Okay. So this is the value we are getting, under root 3 q square by 4 pi epsilon naught into L square. I hope you got the answer. How did we have found the vectors, and how did we find the resultant vector, and how did we used the parallelogram law of vector addition. So this is as simple as you can see. Practice it, learn it, and try to use the formula here and there. Understand how we are getting the formula as I have explained, and hope this class is useful for you people. Okay, bye bye.